Okay, please confirm if my screen is visible.
Visible.
Okay. Then. So we were discussing about the Java operators, isn't it? Java operators. So we have completed unary operators. We have also completed arithmetic operators. So unary operators completed, arithmetic operators has been completed. Right. Today we will understand about the operators which is called as the relational operators. Relational operators in Java. Okay. What is a relational operator? So there are only four operators under the relational operators category. So one is you have the greater than operator, you have the lesser than operator, and you have the operator like greater than equal to, and you have operator like lesser than equal to. Right? This greater than operator, these relational operators are used to compare the two variables. They are just used to what? They are used to compare the two variables. What does it really mean? So when I say greater than operator, okay, this operator, this is greater than operator. It is used to compare two variables. This operator is used to compare the two variables. 1 minute, guys. This operator is used to compare the two variables. Okay, so it is very easy. Mathematically, we know what is a greater than operator. So this operator will return true if the first value is greater than the second value. Very simple, isn't it? This operator returns true if the first value is greater than the second. Greater than the second one. Example. Let us say that I want to make a relation between two variables. One is 5, the second one is 10. Okay. We want to make a relation by using the relational operator. Let us use the greater than symbol. I'm using the greater than operator. So when you give this piece of code to any human being, when you ask someone to pronounce this, what they say, 5 is greater than 10. Okay, but ideally they cannot interpret. Okay, they cannot say that what is 5 is greater than 10. It sounds something illogical because 5 is not greater than 10, isn't it? So if you give the same piece of code to Java, Java will interpret in such a way that when you say 5 is greater than 10, it says no, it is not greater than 10. 5 is, it is completely invalid statement. How it would answer that the statement is invalid? By printing the value as false in the console. Because it is invalid, right? Invalid in the sense, it is completely wrong. 5 is not greater than 10. When you give this piece of code to Java would say what? 5 is not greater than 10, so answer is false. You do the opposite. If you say 5 is lesser than 10, 5 is lesser than 10. This time, this is valid. Okay, how the valid answer would be answered by Java? By saying it as what? By returning something like true. Right? So this is about the greater than operator. This is about the lesser than operator. And you have such operators like when I say 5 is greater than or equal to 5 again. Or else I can say that 5 is greater than or equal to 3. Okay, any one condition, if any one condition is satisfied. Very simple, no? 5 is greater than 3. Of course, the condition is satisfied. Of course, it is going to return what? True. Going to return. And again, if you have something like 5 is lesser than or equal to 5. This time, 5 is not lesser than or equal to 5, not lesser than 5, but 5 is equal to 5. Okay, one condition is getting satisfied. This is also what the output is going to be what? True. These are the typical examples where we will be using all these operators. in Java, you can use all these operators in the if conditions, in the ternary operators. There are some places where you would be using these operators very, very often for the comparison, to compare the variables. So which variable is larger, which variable is smaller. To get such comparisons, we use these operators. And again, you need to remember one thing. Whenever you are using these operators, always ensure that the return value is going to be a Boolean value. Apart from the Boolean value, you will not be getting any other value apart from Boolean. Return value is evaluated to be a Boolean value. Example, if I ask you, let us say that integer a equal to 10, integer b equal to 20. So I am assigning a value 10 to the variable a. I am assigning the value 20 to the variable b. When I say system dot out dot println, okay, the moment I say a is lesser than 20, I have an option. I have an option to do the comparison. Okay, I want to compare. I want to compare it in the runtime. A is lesser than b. I can also say that. I can also compare it like if a is greater than b. I can also compare it like if a is lesser than or equal to b. I can also compare it like if a is greater than or equal to b. This is going to get evaluated. Okay, this is going to get evaluated in such a way that the output would be either true or false. Let us complete this first evaluation. A is greater than, A is lesser than b. Is it valid? Yes, a is 10 and b is 20. This is completely a valid statement. Okay, it is going to return what? True. Okay, and again you are using a relational operator to compare two variables. This time you are saying a is greater than b. A is greater than b. That is a contradiction. 10 is greater than 20, so it is false. It's not valid, so it will return false. The third case is what? The third case is same as this one. A is lesser than or equal to 20. Of course, it is lesser than or equal to 20. True. The fourth case is same as the second one. Okay, which says a is 10 is less greater than or equal to 20, which is invalid. It is false. So the idea is here is to understand that you can use it directly in the system.out.println statement for the comparison. Second thing, you can also do it in a different way. Let me take a variable like Boolean. Okay. Let me take a variable name like Boolean. I am saying Boolean x equal to a is greater than or equal to 10. Boolean x equal to a is greater than or equal to 10. Okay, this will get evaluated. Okay, this will get evaluated in such a way that the output would be either true or false, because the comparison is happening. How the comparison is happening? You want to compare whether the variable 10, whether the variable a, which has the value 10, okay, is greater than or equal to the actual value 10 itself. Is greater than or equal to actual value 10 itself. So after the comparison, there will be a resultant value. Okay, the resultant value is going to get generated in the form of Boolean data type. Yes or no? You can write any kind of statement here, but the resultant value should always be a Boolean value, which can be true or it can be false. Right? This is what. Always remember, the comparison, the relational operators is going to give the result in the form of true or false. True or false. In this case, it is true. Let us execute this. Let's see how we are getting the answers. Java C space a dot Java space. We get true, false, right? True, false, true, false. If you want to see this answer, we can also see that by using the system dot out dot println statement. Okay, and you can take this x variable to get printed in the console. What is output? True, true, false, true, false. You are getting this. This is all about relational operators. So in the real-time application, we will be doing a lot of comparison between one variable to the another variable, right? Next thing is, okay, so we have understood about greater than operator. Let me remove this. Okay, and we have also have what the lesser than operator. Lesser than operator. What is the use of lesser than? This operator is used to compare two variables. Compare two variables. And the resultant value will be always in the form of Boolean. Okay. Same thing we can write it for greater than or equal to. Greater than or equal to. Okay. Greater than or equal to. Okay. And same thing goes for what? Same thing goes for lesser than or equal to. Lesser than or equal to. So comparison, they will just do the comparison, and the resultant value will always be in the form of Boolean data type. So this is all about what the relational operators. And the next operator is very important operator. Stay focused here. So you have an operator like the ternary operator. Okay, very interesting. Focus here. So you will be using this operator to do a lot of mathematical calculations. Ternary operator. What does it mean? Ternary. Okay. So ternary means what? Ternary means they have one condition, guys. They have one condition followed by two statements. Let me write the syntax here. Syntax. I will explain you what the ternary operator is. Let me write the syntax. Syntax is like, okay, you have a condition. You will check a condition. If that condition is satisfied, okay, the first statement after the condition will execute it. The condition is not getting satisfied, the second statement after the condition will get executed. Value if, let me give you the simple example. Let me take a program. Okay, so I want to take the return type. Let us take the return type as Boolean for the time being. Okay, I want to check a condition like, hey, can you check if the number 10 is greater than 5? I want to check a condition. Hey, can you please check if number 10 is greater than 5? Okay, this is true, isn't it? Number 10 is greater than 5. Yes or no? If this is returning true, okay, if the condition is satisfying, okay, if this is returning true, okay, you will display what? The first statement will get executed. So there will be two statements followed by this conditional check. You can write whatever here. Okay, let us say, let me write true here for the time being. Let me take false here for the time being. If I try to print system.out.println, if I want to print x, let me execute this. Output is true. True is displayed in the console. What is true? Why true is displayed in the console? Look at the syntax and compare that syntax with this simple piece of code. Okay, here what you are doing, let me separate this for the better observation. Now you see, guys, you have an equal to operator, assignment operator. Always remember the RHS side will get evaluated first. The resultant value gets assigned to the variable. Okay. Now the control will start executing from here. It will execute from here to here. Right. Firstly, the conditional check is happening here. It will check if 10 is greater than 5 or not. What is the output? Output is what? Output is true. Because you are using the relational operator here, right? 10 is greater than 5. Question mark. You are asking the question. What question you are asking? Hey, can you check if 10 is greater than 5? Okay. How the answer will be given to you in the form of Boolean? True. It is true. When it is true, when the resultant value is true, okay, it will execute the first instruction. It will execute the first statement as soon as the conditional check. First statement is true. So true will be displayed on the console. For example, let me reverse this. Okay, I am asking a question which is something a contradiction question. I am asking a question like, hey, can you check if 10 is lesser than 5? Okay, can you check if 10 is lesser than 5? Now focus here. Can you check if the 10 is lesser than 5? You are asking a question if whether the 10 is lesser than 5 or not. It is not lesser than 5. Okay, this is going to get evaluated to be what? False. When this is getting evaluated to be false, the second statement after the conditional check will get executed. This is the idea. This is just an idea. Right? True means first statement, false means second statement. Just keep this in mind. True means first statement, false means second statement. Right? After performing the conditional check. So the first thing always has to be a conditional check, followed by two statements. You can change this, you can manipulate these statements according to the requirement. Remember one thing, in this case, I am placing a what? I am keeping the return type as Boolean. Okay, I am keeping the data type as Boolean. Why I am keeping the Boolean here? Anyhow, the resultant value is going to be true or false. So this true or false has to be stored in a particular data type, which is what? Which is the Boolean data type. That's why I have kept Boolean here. Let us see another example for the better understanding. Okay, I want to check something like, let us say that integer a equal to 100, integer b equal to 50. Okay, I want to execute like a greater than b. A simple conditional check. A is greater than b. Okay, and I am keeping something like first statement. Okay, and there is another thing like second statement. So there is a conditional check. This conditional check will get evaluated to be true or false. So when it is returning true, the first statement after the conditional check will get executed. When it is returning false, the second statement after the conditional check is going to get is going to get returned. You see this, these two statements are of what type? String type. By looking at these two statements, you should be in a position of understanding what is the return type of this particular ternary operator. You are returning string here. It is stating it. It is very clear that return is string. That's why you would store the resultant value in a string data type. Okay, now if I execute this, can you tell me what would be the output here? Anyone? Do we get first statement or second statement? Okay, let me execute this for you. You will get first statement. Okay, now let us understand this further. Okay, let me keep some spaces for the better observation. Focus here. Focus here. So you have three checks: conditional check, your first statement, your second statement. This cannot be first statement or second statement. It can be anything. But you need to observe one thing. Okay, these two statements is of what type? These two statements is of what? String type. When the statement that is after the conditional check is of string type, then you should be ensuring that you are using the string data type to capture that. Right? So you are evaluating a is greater than b or not. What is the value of a that we have taken? 100. Right? 100. What is the value of b that you are taking? 50. The conditional check will be performed. You are using a relational operator here. Okay. What would be the answer after checking this condition? True would be the answer because it is true. So when it is true, execute the first statement. When it is true, execute the first statement after the conditional check. Okay, what will be the output? This first statement will be returned to the res variable. First statement will be stored in the res variable. Res equal to first statement. Right? If I make a little change, if I do a little modification here, okay, now you tell me what would be the answer. Come on. I'm using A is
Second statement.
second statement would be the answer. Why second statement? Because this gets evaluated to be false. When the resultant value, when the condition is getting evaluated to be false, execute this second statement. Here I'm using the second statement directly. Execute the second statement. Now you tell me what would be the answer if I do something like no? Now you tell me what would be the answer. A is
First statement.
first statement would be the answer, isn't it? Because this is going to get evaluated to be, let me show this. First statement. Why first statement? This is going to get evaluated to be true. A is lesser than or equal to what? B plus 50. B plus 50 is found to be 100. B is 50 and again 50. Again you are doing indirectly, you are comparing 100 is lesser than or equal to 100 or not. Of course it is going to be true. That's why you get the first statement as a concept. Okay, now you tell me, okay, let me let me take another example. So I'm taking integer. I will help you with the use cases. Okay, try to understand the concept. Okay, try to understand the execution part here. I am doing A is lesser than B question mark. Okay, I am saying 1000. I am saying 2000. If I execute this, what would be the output now?
1000.
1000 is output. Very simple here. You don't get any confusion. Okay, see. Ternary operator. So when I say ternary operator, you will be dealing with a conditional check first. First evaluate this condition. Check for the answer. What it is going to get evaluated to be what? Is going to get evaluated to be true. Okay. When it is returning true, just by blindly, okay, the first statement gets executed. When this is returning false, okay, the second statement gets executed. That's it. Very simple. Why confusion? Second statement is getting executed. So you want to develop a logic in such a way that you are going to develop a lot of use cases. So this is the basic understanding about the control flow. Depends upon this condition, it will execute whether the first statement needs to be executed or the second statement needs to be executed or not. That's it. Why I have taken integer as the return type here? Because if you look at these two statements, they are part of integer category. That's why return type is integer. Right? Let's see another example. Now I want to the use cases. The first use case. Focus here. First use case. I am taking a variable integer a equal to 10. I am taking a variable integer b equal to 20. I want to find the maximum number between these two variables. Which is the maximum number I want to find? By using ternary operator. I want to find what? I want to find the maximum number. How I can find? I want to say integer c equal to, I will place a condition in such a way that a is greater than, or a is lesser than 20. Conditional check. Okay, conditional check. If this condition is getting satisfied, if this condition, let us take a is, we are finding the maximum number. Let's say that a is greater than 20, greater than b. A is greater than b. Conditional check will happen. Okay, if a is greater than b, if a is greater, return a, or else return b. Let me print system.out.println. Let me print the value of c. 20 we are getting. We are getting the output as 20. Why we are getting output as 20? Focus here. This is the used case. Focus here. Okay. So here you are using the ternary operator. Let me expand this. A is greater than b. Conditional check. Okay. Followed by the statement 1, which is a itself, followed by statement 2, which is b itself. Okay, so this A is lesser greater than B. What does it really mean? It is doing a check whether 10 is greater than 20 or not. Okay. If 10 is greater than 20, if 10 is greater than 20, this is invalid, right? It is going to return false. False means the second statement will get executed. B will be displayed in the console. The value inside the B will be displayed in the console. What is the value inside the B? 20 is a value inside the B. So you are getting the maximum number with this logic. Let us try to manipulate this logic. Let me change the value to A as 100 and B as 20. Let us see if you are getting the maximum number or not. 100 maximum number. Let me increase B as 200 this time. Now I have A as 100, B as 200. I want to get the maximum value. What is the maximum value? Maximum value is of 200, right? I should get 200 in the console. This logic is applicable for all the combinations. 200. How it is applicable? You are just checking a condition, and it's your job to ensure that, okay, if the first statement is getting executed, it has to be in such a way that it is always returning the greatest number. The second statement is getting executed, it should be in such a way that the second statement should be a greatest number. You should write logic in such a way. So this is how the logic can be written. How I can ensure that this has the better viewing? I can say that maximum number is, let's see, whatever the combination that you give, at the output you will get the maximum number. Whatever the combination you give, you will get the maximum number. Let's try another concept. Java C space A dot Java. Maximum number is 200. Let us increase the value A to 1000. Now let us see, are we getting the maximum number? Java C space A dot Java. Java space maximum number is 1000. The ternary operators are used to do the comparison, and this is one of the use cases. If we want to find the maximum number among two variables, this is the logic. What if I want to find the minimum number? Simply I will do a logic like integer d equal to A is lesser than B. I will just change the relational operation here. Instead of greater than, I will use lesser than symbol, and I will keep the same things. Okay. Now the variable d is going to return the minimum number here. So if I give two combination of numbers, I can able to find what is the maximum number. I can able to find what is the minimum number. Okay, plus, I have 1000, I have 200. So 200 should be in the minimum number and 1000 should be the maximum number, isn't it? Okay. Are we getting the same thing? Okay. Minimum number is 200, maximum number is 1000. Are you getting this? Yes, no? Type something in the chat box, everyone. Yes, no? Let us keep the session interactive. Are you getting this? What I'm trying to say? Conditional check, ternary operator. Everyone at least type yes in the chat box. Balaji, Lakshmi, Sudhir, Teja, Monica, Dinesh Kumar, Prasanna, Revati, Ikan. If you want me to repeat, I can repeat it once again. Okay. So sometimes in the real-time examples, this is just I can say that this is just a substitute to if-else condition. If-else condition. So you would do the same thing. If you want to perform the same operation, you can do that by using if and else statement. We will discuss that in the future topic. Okay, this is a good alternative to use. Instead of if and else statement, you can go for this as an alternative because you can perform the comparison in a single line. And also you can do a lot of complex operations also that we will discuss in the future. Complex operations in the sense I can do these nested checks. Keep doing this nested check, a check within a check. You can also place nested check here. You can increase these checks. We will do that in the future topics, future concepts at the time of writing the Java programs. Okay, now this understanding is enough. This understanding is enough for now. Okay, so let us try to let me give you what is ternary operator. It is a one size. concise way to write a simple if-else statement. Okay, it consists of three parts. It consists of three parts. What are they? First one is conditional check. Okay, a Boolean expression that evaluates to be the true or false. That gets evaluated to be true or false. Second one, value if second statement is first statement, value if true will get executed. Okay, the statement that is after the condition that will get executed. Value if true. Okay, the value to return if the condition is true. Return the condition is. Third one is value if false. The value to be returned if the condition is syntax. What is the syntax? Syntax is very simple. Okay, you will have condition, a conditional check, value if true, value if false. And the return, okay, the value that you're placing here, okay, the values that you're placing here, if this value is of integer type, you should ensure that this value can be any type, isn't it? This value can be any type. It can be integer type, or it can be Boolean type, it can be a string type, whatever it is. It can be integer type, it can be Boolean type, okay, it can be of string type. Okay, based upon these types, you will what? You will catch this. You will store this variable accordingly. You will store this variable according to the return type. Okay, if it is Boolean, you will use the Boolean data type here. If it is integer, you will use integer data type here. If it is string, you will use the string data type here. Right? So this is all about what conditional check. And if you see this, look, let us see this. You are using, okay, this ternary operator is using three combinations of operators again. You're using the assignment operator. You're using the relational operator, right? The combination of assignment operator, the combination of relational operator. Okay, and you're using something like the conditional question mark is nothing but it is checking a condition. That's it. Okay, if this is evaluated to be true, this will be returned, else this will be returned. Okay, now the next operator is what we want to discuss about, what the logical operators, short circuit logical operators. What is the short circuit logical operators? Logical. Now I will ask you a question, an interesting question. Let us see who is going to answer this. I am taking two inputs. One is A and second one is B. I want to check A and B. Okay, if the combination of A, okay, the inputs of A is something, A is like true and you have also true here. Likewise, I'm taking four set of combinations. True, false, false, true, false, false. If I perform the logical AND operator, Right? What would be the output? Anyone can say this. What would be the output here first? True and true gives what?
True.
True, it will give true. Right? True and false gives false, isn't it?
False.
False and true is going to give false.
False.
False and false is going to give. And again, I have a follow-up question. What would be the answer if I do this? I am using 2 ampersand here. Previously, this is single ampersand. I am using 2 ampersand here. Is it valid? First, if you ask me, is it valid? Of course, it is valid in Java. If I ask you what would be the output if I do this, what you would say, sir, logically both are using ampersand, so both are talking about the AND operator. So this is the AND operator, isn't it? Of course, the answer is going to be same: true, true, false, false, false. This could be the answer. And the interview room, if you answer this, that would be a follow-up question like, then what is the difference when you use the single ampersand and when you use the double ampersand? Okay, let me explain this for you. What would be the difference? What would be the ideal difference when you use a single ampersand, when you use a double ampersand? Now focus here. So this is going to be what? The first one. Okay, this is going to be it is just the logical AND operator. It is just what? It is just what? Logical AND operator. Okay, and when I want to describe this, where I am using 2 ampersand symbol, I would say that this is short circuited logical AND. Short circuited logical AND. Logical AND. Sir, what difference is there between these two operators? Both are performing the same operation, and both are returning the same value. What difference is there? What kind of difference that we can see by using these two combinations? They ask me the performance wise, this is going to be what? Performance wise, going to be less in performance. Okay, when the performance wise is going to be what? Very high in performance. Where is the proof? Let me give you a small example here. Focus, okay, stay focus here. The example would be like, what example we can take? Okay. So people who have mixed my previous class, focus here. I am taking integer a equal to 10. I am also taking integer b equal to something like 20. System dot out dot println. What I am taking here, I am saying a plus b is greater than or equal to 30, and I'm taking a plus b is double equal to 30. So I'm using this single ampersand symbol, which is representing the AND operator. If I execute this, what would be the output? Can someone say?
True.
Output is going to be true. Why it is going to be true? First, this statement, let me show the output. Output is true. So we know this clearly. Okay, this statement is what? This statement is returning true. Because a plus b is what? A plus b is 30. 30 is greater than or equal to 30. Equal to condition is getting satisfied. So you get true. Straightforward. And you're using an AND operator. Again, a plus b, which is 30, double equal to means comparison, double equal to 30. You are comparing it. Right? Again, it is going to return true. So according to the table, let us go back and see the table. True is going to give true according to the truth table. Now let me make a small difference here. Now you tell me what would be the answer now.
True.
Okay, now okay, I made something. Now what would be the answer?
False.
False would be the answer because the first statement is getting evaluated to be false. The combination of false and true is going to be false. But in this case, Okay? Now if I'm using double ampersand here, that there is no difference. You will be getting false here. But what I'm trying to say is, if you use single ampersand, when you do single ampersand, what will happen? Every condition will get evaluated. So this is false, right? It gets evaluated, and this is what? This is true. So this is also going to get evaluated. But the moment I start using double ampersand, ampersand, when the compiler finds, when at the time of execution, when it finds the first statement is found to be false, it will not check the second statement. Okay, let me put this in the plain screen. Focus here, guys. Focus here. Very, very important. This is very, very important. We'll see some beautiful examples on this. First, understand the concept. There is a lot of difference between this one and this one. One major difference that we can observe is what? What is a major difference that you and me can observe? Sir, you are using single ampersand, you are using double ampersand. I can say that since you are using single ampersand, this is just a logical AND. This is just the logical AND operator. Logical AND. So this is short-circuited logical AND. Short-circuited logical AND operator. This is the only difference I can observe. What I am saying is, so this is evaluated to be false. In our example, this is evaluated to be false. Okay, and again, there is the logical AND here. This is getting evaluated to be true. Okay, so the moment in this case, these two cases will get evaluated. First case will get evaluated, and second case will also get evaluated. But if you see here, the moment it sees false, the moment it identifies the first condition as the false, it will not spend time to check the second condition, because this short circuit logical AND operator is very clever enough. The moment it sees false in the beginning itself, it will not check the second condition. Why it will not check the second condition? Whatever the answer is, whether it can be false or it can be true, whatever the answer that you get in the second condition, the output will not get affected. Once you see false, resultant value is always going to be false. Are you getting this concept first of all? Yes, no? See, if you see the truth table here, okay, the moment you see false, you do not want to check the true also, because by using a double ampersand or single ampersand, anyhow the output is going to be false itself. Yes or no? If you see false here, you do not have to evaluate the second condition, because output is going to be false itself. Okay, this single ampersand will check all the conditions no matter what. But when you use the double ampersand, or when you use the short circuit logical AND operator, it will check the first condition. If it is false, blind it will say, will not check the remaining condition, it will give the output as false. But over here it will check two conditions. Are you getting this logic? If I use the same logical and same short circuit AND operator with these two inputs, first is it is returning true. Definitely I need to check for the second answer. Then only I can come to the conclusion. But in these two cases, I do not have to check for the second condition's answer, because I have found the false here in the first condition. Definitely the output is false only. Yes or no? Are you getting this till now, everyone? Am I clear? Hello? Yes, no? Are you following?
Yes, sir.
Let us see.
Yes.
Let us see with this practically. Okay, that's why I'm saying the performance is high with the double AND operator. The moment it identifies the false in the beginning itself, you can have any number of conditions. You can have true here. Okay, you can have false here. Again, you can have false here. Okay, it is like the condition statements can be a complex conditional statements. See how many conditions are there? 1, 2. Okay, and let me add how many conditions here? Many conditions here. If I ask you one question, I am going to ask you. If I ask you, what would be the answer? Should be related enough to answer. You should find what operators that we are using here. We are using what? We are using the short circuit operators. When you are using short circuit operators, try to get the false. If you are getting false in the beginning only, you do not have to evaluate the remaining conditions, because the output will be false only. Am I correct? Yes or no? When I say, see, now I am just doing a small change here. What change I am doing? I am using what? A plus B greater than or equal to 30 I am using here. greater than equal to 30 I'm using here. Okay, and if I ask you, in this case, so the first condition is true, right? I need to go and check for the second condition. It is true. Again, I have to go and check for third condition. True, 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 true. I am finding false at the last. So I cannot do anything. This short circuit operator can't do anything. It has to evaluate all the conditions until it finds false. But if it is finding the false in the second location, it can stop checking here itself. Once the false is identified, no matter what the conditions are, the output is going to be false only. Can I say that the output is false now? Yes, no. But if I ask you the same question, how can I say it is false? Because I am finding the false in the second location. Where is the proof that the remaining conditions are not getting executed? Sir, I want to see the proof. You are just saying these are not getting executed. Where is the proof? I will show you the proof now. Focus here. Focus here. Focus here. You practice this, these things are very easy, but at the time of observing this, you will find it very difficult. I am taking integer a equal to 10, integer b equal to 10. Now focus here, system dot out dot println. Let's see who is going to answer this. Okay, a plus plus not equal to 10 and b plus plus not equal to 10. Think and answer me. People who have missed my unary operator classes, you may find it difficult to answer this. Let's see who will be answering this. This is going to give you some insights about understanding the short circuit operator. Can someone answer this? Whether I think you know Prasanna, I don't know Prasanna.
False. False.
What is the first one?
False.
What is the answer here? Okay, let me show the output. Focus here. Don't get panic. You are getting false 11 11. You are getting what? Output as false 11 11. Now focus here, guys. Very, very important. We'll keep it very, very simple. Just pay some attention. The main thread gets executed. Main thread gets access to the main method, first instruction, and you have second instruction. So directly you can take two memory spaces. Okay, one is for variable A, one is for variable A, second one is for variable B. Okay, value inside the A is 10 and value inside the B is also 10. Now focus here. Now focus the third line. Third line is something, something like I have used A plus plus followed by not equal to followed by 10, and I have used AND operator. This is what? This is the logical line, just the logical line, not the short circuit line. I am using A B plus plus. I am using not equal to. Let's start executing from left to right. First is what? A plus plus post increment. What is it? Post increment. What is the value inside the A? 10 is the value. That 10 value will be retained first. 10 value will be retained. Okay, because this is post increment. First, you are doing what? You are taking the value 10. Retain the 10 value, then do the increment. If I want to do the increment after the retaining, in the memory, I have to increment it by 1. A plus plus means increase the value by 1. How you will increase the value? That is the question. First, retain the value 10, then increase it. So what is the next statement? Okay, you are using a comparison. Okay, not equal to. Okay, not equal. What is the next statement? Next statement is what? Next is what? The value 10. Okay, this is going to get evaluated by 10 not equal to 10. Okay, it is false because 10 is equal to 10, isn't it? Okay, next, what is there? You are using the single AND operator. Single AND ampersand operator. Now focus here. what is the next instruction? B plus plus. B plus plus means post increment. First, retain the value inside the B. What is the value inside the B? 10. Retain that value first. Get that value first, then perform the incrementation. Get that value, retain that value, then perform the incrementation in the memory. 10 becomes what? 10 becomes 11. Okay. Again, after this, what? 10 is not equal to 10 itself. So the combination of, the complete resultant value, 10 is not equal to 10, is going to give you what? False. Right? What is the value of false and false? The combination of false and false is false itself. That's why you got output as false here. What you are trying to print here next? You're printing A. What is the value inside the A11? You're printing B. What is the value inside B11? That's why false 11. Are you getting this? So far, are we clear? Yes, no? Everyone? Please speak up. Yes, no?
Yes, sir.
Now see. Next thing, I am just changing the logical AND to the short circuit AND. If I ask you the same question, what would be the output? If I ask you the same question, what would be the output? Let me run this. Output is false 11 10. Focus here. Output is what? False 11 and followed by. Why there is a change? Previously, we are able to see the output like false 11 11, but this time false 11 10. Where are we missing anything else? Now let's try to understand it. Okay, focus here. This is short circuit and okay, this is short circuit. Same thing I am doing. Okay, the main thread gets access to the main method. All the instructions will get executed one by one. Okay, first one is what? A. Second one is what? B. Okay, and you have B. The value inside A is 10. The value inside B is what? 10. Now look at this next instruction. You need to evaluate this, right? Let me take it here for the better observation. A plus plus not equal to 10 and B plus plus not equal to, focus here. Okay, the execution will start from left to right. So A plus plus, what is the value inside the A? 10. Retain that value first. Get that value first. This is the operation of post increment. If you don't know this, repeat. See my previous unary operator videos. There I have given you the complete explanation. You have missed the classes. 10. Retain that value 10 and do the increment in the memory. Plus plus. Increment it by 1. 10 becomes 11. Okay. Now focus here. Next thing is not equal to. You are doing what? Not equal to. After this, you are doing what? You are taking the value 10. Now do the comparison. Hey, can you please compare if 10 is not equal to 10? What is the value if you do the comparison? 10 is not equal to 10. False. Because 10 is equal to 10. You are doing, there is a contradiction here. So this is the short circuit operator. You are using what? You are using the short circuit operator. Double ampersand. When you do the double ampersand, the moment it gets the false answer, okay, this part will not be evaluated. This part will never be evaluated because it has got the answer. It has got the answer. Where is the proof that this part is not getting evaluated? If this is getting evaluated, this has to become 11. Since this is not getting evaluated, the output is going to be what? The control will stop executing. Here, this will not get evaluated. Then the next control will be like, okay, value of A will be printed. What is the value inside the variable A? 11 will be printed. Next control will go to the next line where it is printing value B. What is the value B? 10 is the value. That is why there is a difference between the previous expression. Okay, here you are using what? Logical AND. Logical AND means everything is to get executed, no matter what. But short circuit AND means the moment it finds the false, right? It knows clearly that executing the remaining statements are nonsense, time waste. That's why this is the ideal proof that the next statement is not getting executed. Are we clear, everyone? Yes, no? Any confusion? Type yes in the chat box or no in the chat box. Whatever it is, you can please type. You can express your opinions, no issues. Everyone. Dinesh, Monica, Lakshmi, Balaji. Don't think Balaji will know. Whatever it is, express it. If you want me to explain a different way, I can do that. Okay, now, like this, we have something like, see, this is like just like, see, guys, every day, see, if you want to think something logically, logical thinking, how you will do a logical thinking? For example, you want to visit a temple, guys. You want to visit a temple. Okay, the condition to visit a temple, right? So you are visiting the temple after 7 p.m. Okay, outside the temple, just for an imagination, I'm taking, saying there will be a security guard. Okay, security guard would be asking 3 questions. What is that? Morning, what you had? Afternoon, what you had? Evening, what you had? First person is coming. He's asking, hey, morning, what you had in the morning? I had vegetarian. What you had in the afternoon? I had vegetarian. What you had in the evening? I had non-vegetarian. Hey, since the non-vegetarian, the condition is he should not be having non-vegetarian. Since he had non-vegetarian in the evening, he's not allowed to the temple. Second question. Second person is coming. Same question. Morning what you had, afternoon what you had, evening what you had. What would be answer? Okay, morning. Let us say that he is saying that I had non-veg in the morning. So do you think that he's going to ask what you had in the afternoon, what you had in the evening? No. The first answer itself is very clear. Since he had non-veg, there is no requirement to ask what he had in the afternoon, what is had in the evening. Definitely, he is not allowed to the temple. This is the ideal case. This is just an analogy to understand this. When the moment you find false, the beginning itself, no matter what, the short circuit operator will ensure that remaining conditions are not checked. And now the output is going to be false only. Likewise, like we have the short circuit and operator, we have also have what short circuit or operator. When I say or operator, let me take the truth table. A, B, A, or B. If you get locked out of the meeting room, please rejoin. This is going to be only for 10 more minutes. A or. Okay, let me say true, true. True, false. This is the truth table I'm writing. False, true, false. Can I help you with the answers for this? Combination of true, true is going to give what in the OR operator?
True.
True only, right? Combination of true, false, true.
True.
Combination of false, true, true.
True.
Combination of false, false,
False.
false. Right? The idea here is if one is true, output is true. Right? Same thing applies for this also. This is the short circuit OR operator. The first one is the logical operator. Second one is the short circuit OR operator. The behavior is same like the AND operator. The behavior is same like the AND operator, but try to understand the concept here. If I ask you, sir, both outputs are, you can ask me, sir, both outputs are same. What is the difference? I would say that this is just the logical OR, okay? Logical OR operator, and this is just the what? Logical AND operator. See, short circuit AND operator. Short circuit logical OR. Okay, so we have what? We have the logical OR operator, right? And this is what? Short circuit logical OR, short circuit. Okay, now let me take a small example here, small program here to understand this logical OR and the short circuit logical OR. This program is going to be like same like this. I will make some modification here. I am doing a plus plus equal to 10, b plus plus equal to 10, and I'm using the or logical OR here. If I ask you the question, what would be the answer for this? I'm using OR condition here. Okay, I want you to evaluate this. What would be the answer?
True 11 11.
So true 11 11. Let us try to trace this in the program. Let me utilize this space. Okay, so the 10 will be stored in the memory of A. Okay, there is A and there is B. The value 10 will be stored here and value 10 will be stored here. One of the 10 values will be assigned to A. Okay, and the value 10 will be assigned to this value 10 will assigned to B. So what is the third instruction? You have the complete instruction like A plus plus double equal to 10. You're using the OR operator. B plus plus double equal to. So the execution will start from left to right. You're doing what? You're doing A plus plus. Now focus here. You're doing A plus plus post increment operator. Post increment is first you're finding A, retain that value first, retain it, get that value from the memory, then do what? Then increment the value inside the memory by 1. Plus 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 means was increment operator. Increment it to by 1. 10 becomes 11. So this is done. Okay, and you're doing what? You're comparing by using double equal to operator. Double equal to operator. Again you're doing 10. 10 equals to 10. Of course, it is equals to 10. So it is going to be what? True will be written in the console. Right? And next you're using the OR operator. This is the logical OR. Logical OR. When you're using logical OR, right? The second condition will also be checked. See, the moment you get true, we are very clear that whatever the values that you, whatever the logical entities that you have going forward, the resultant value is going to be true only. But this logical OR operator will check the second condition also, because this is the logical OR. Even though it is getting true, it is not clever enough to stop the what? To stop checking the remaining conditions. It is not clever enough. It will check the second condition also. A B plus plus. So B plus plus is what? First take the value from B, which is 10. Okay. Plus 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 means what? Do the increment in the memory. 11. Okay. Followed by double equal to 10. So this is going to be true. True or true is going to be true only. That's why output is true here. What is the value inside A? 11. What is the value inside B? 11. Okay. The moment I change this logical OR to short circuit OR. Okay, now if I ask you what would be the answer, can you tell me now what would be the answer?
True 11 10.
True 11 10. Very good, very good. So this case we are understanding, we are not understanding about the why we are getting 10 here. We are understanding about this particular conditional is not checked. This is skipping, this is being skipped. As soon as it finds this is true, it is not going to check the remaining condition. Okay, it will skip this, keep checking this. It knows clearly that once the value is true, the output is true only. This is the kind of proof. Let me execute this for you. use this space. Okay, and the main thread will get created, or there will be two memory spaces here. One is A and the second one is B. Okay, value A and value B. Okay. Right, now we'll take this third line, system.out.println A plus plus equal to 10 or B plus plus equal to 10. Execution will start from left to right. A plus plus, what is the value inside A? 10. Get that value, retain that value first. Okay. Plus plus. Plus plus means increment it by 1, which is going to become 11. Okay, followed by what? Followed by you have double equal to operator. Double equal to operator of 10. Right? 10 double equal to 10. What it is going to give? True only. So it has we got, okay, this is the short circuit operator. It has found the first answer. When it finds the first answer as the true, this operator, the short circuit operator, will not go and check for the remaining errors. It means this second conditional check will be skipped. This second conditional check will be skipped. This will not get executed. Where is the proof that it is not getting executed? If this is getting executed, this value has to become incremented by 1. So it has to become 11. Since this value is not getting incremented, this is the complete proof that this is getting skipped completely. That's why in the output you are getting what? You are getting true. You are getting true. You are getting the answer as 11, and you are getting answer as 10. They ask you the next question, something like, okay, now you tell me, what if I do? Now what would be the answer?
False 11, 10.
False
11, 10.
false 11 10 now. Let's see. True 11 11. Okay, now focus here. We are using short circuit OR operator. Okay, now think practically. You're using A plus plus. Okay, first retain the value of A. Value of A is what? Value of A is 10. Retain it. Okay, and increment it. Increment the actual value from 10 to 11. This A will become 11. First retain the value, then perform the increment. Okay, now you have 10, you are comparing it with 11. When the 10 is getting compared with 11, what would be the output? Okay, 10 is double equal 11. Output is going to be what? False. This is, we are using logical OR. We are using logical OR, which means this value is not sufficient enough to display the result. It has to check the remaining condition also. It has to check the next condition also, right? Because we are using logical OR. When it is true, it is okay that next condition can be skipped, but it is false. There are chances that the next resultant value can be false. It can be true. Okay, this is required. This is required to give the exact answer. Right? So this will also be executed. B plus plus. What is B? Value of B. Value inside the B is 10. Retain that value and perform the increment in the memory. 10 becomes 11. Okay? And again you are using what? 10 double equal to double equal. I'm sorry. 10 is getting compared with 10 itself. 10 double equal. Sorry. 10 is compared with 10 itself. 10 double equal to 10. This is going to be what? Which is going to be true. The combination of false and true in the logical OR operator is going to be true only. Output is true only. And if you look at the memory level changes, the value inside the A is 11. The value inside the B is also 11. Are you getting Sudhir? Everyone? Yes,
Yes,
no?
sir.
Because this first condition, if it is true, it will not execute the next condition. But if it is false, the value of next condition is required for the logical OR operator. For the logical. But if I change this to AND operator, then the result will be something different. Yes or no? Now tell me the answer if I change this to AND operator. This is the last example. We can conclude this.
False 11,
Wait,
12.
wait. No. Now you tell me.
False 11, 10.
False 11, 10. Na? False 11. Good. False 11, 10. Why false 11, 10? See what kind of operator we are using. We are using short circuit and operator. So first let us start executing A. A means retain the value of A, which is 10. After the retention, do the increment. Okay, the 10 becomes 11. Right? And this 10 is getting compared with what? Getting compared with 11. This 10 is getting compared with 11. You get what? You get false. So when you get false, when at least one of the inputs is false, go and look back the short circuit and operator. Okay, when the one of the input is false, when you find the first input as false, you do not have to check the second input. The resultant value is false itself. Right? So this second condition will be skipped. What is the latest value in the A? 11. What is the latest value in the B? 10. That's why false 11. This is all about the short circuit operators.